Hi, thanks for joining me here in my shop this morning. I'm going to be starting to take a serious look at this receiver, which goes with the amplifier. I have just spent, what did I spend? 4 days, 5 days on that amplifier. That amplifier's got 3 parts in it. This has got more than 3 parts in it. Oh my gosh, I wonder where we're heading with this. So what I've got in mind with this radio, since my understanding is it's in working order, is to get it working here on my bench right away. Before I do anything more with it. There were a couple of components that came loose underneath. I reconnected them last time. I believe I sort of tested this with the amplifier, and because the amplifier was humming, I didn't get very far at all with it. So here we are with it. Now what I'd like to do though is hook it up so we can run it and hear it, but not have that amplifier involved. It's just that many more hot tubes in here taking up more space on my bench. Surely to goodness I can tap out a signal from here and avoid requiring the amplifier to be up here too. So I'm pretty sure of that. And just on that note, I'm going to continue on this angle of how to operate this so we can hear it, and but not have the amplifier connected. So there's the 245 tubes here, which in many radios these are the output tubes driving the speaker, but in this radio they're just driving the next set of even bigger tubes. The output transformer for these tubes is in the amplifier chassis, and there's a cable, it plugs in here I'm sure, that actually carries over the B plus into the output transformer, and then the B plus returns through the output transformer, leads to the plates here. If I don't plug in that amplifier, I'm not plugging in the output transformer for these. So the plates on these 2 tubes would be hooked up to nothing. I think that's okay. I think that's actually okay. Why would that be a problem? So if I were building, if I were on my way if I were a manufacturer and I were going to build 5,000 of these units, would I build them in such a condition that if this was pulled out, if the plug to the amp was pulled out and somebody turned it on, that there'd be a crisis immediately? I don't think I would. I think I would make sure that whatever it is I did, a few reasonable mistakes made by owners could be tolerated. One of them would be operating this without the amp plugged in. So I'm really quite reassured. In fact, I can even pull these tubes out if I want and have them completely out of the picture, which is I think that's what I'm going to end up doing. So then if there's no audio to be listened to coming from here, where am I going to get it? I'm going to get it off the volume control. And you know, that could be really easy in this radio, because the volume control is right up on top here. Is it? Oh, maybe not. Maybe not. Maybe not. So we got too many knobs on here. So this is either volume or tone. And this is either volume or tone. So I believe I read the on-off switches on the tone control. So I think this is the tone control and this would be the volume control. And put an operator into this kind of position like this. Because when you're operating a shortwave radio, you generally want to have your hand on the volume control. Turn it up between stations and down when you hit the loud guy. Wow, you see, that was kind of exciting. Fastest tune-in radio in the West. So, okay, well, soon for now this is the volume. All I got to do is just tap right on the volume control here, and then the signal will just, I can send it off to another amplifier and speaker in my shop, or I can feed it right into the audio system you're listening to me with, which is what I think I'll probably do. Okay, I think that's going to work great. Now, is there anything else we need to think hard about before trying that? I don't really think so. By the way, if you're wondering what this is the socket for the Magic Eye tube, which is mounted in the cabinet separate. It's got a clip and it hangs up here in the cabinet, and that's why this is just wandering around now. It's got no place to go. Let me give it a place. There. go there. Now, what if I were to operate it without any audio output of any sort? Why do that? Well, you could be doing voltage tests and stuff like that. Again, I think with the output transformer missing and with these tubes eventually pulled out, I just don't think there's any harm that can come to it. It's really no problem. Good. Just got three tuning capacitors. This is a beast of a radio. This is quite the beast of a radio. 2 IF stages. I'm not sure yet what this transformer is here. This looks like a choke coil here. This looks like a choke coil here. I'm not sure. Big capacitors here. These look almost certainly replaced. Now the guy who did the work on this, it's quite evident in the amplifier, was a person with a lot of skill and experience. That skill and experience no doubt is all over this radio too, so it could be a lot of clever stuff in here. Let's flip it up and take a look again. I've been through this guy once. Oh, right. Right. I'm remembering some things here about it. These resistors here. Maybe I want to investigate these two resistors. This one was getting fairly warm. Of course, I think this is supplying the B plus over, well, it's supplying the B plus to the 245s through the amplifier and back. The 45's out of the picture, there'll be no current in this resistor. It won't be hot. I'm going to have to stop now and go deal with my crying cat. It's just crying. Okay, I'll keep my cats happy for a while. So approaching a project here, or like a complicated one like this, where someone has done something and who knows what, if anything, is a bit of a paralyzer, frankly. So right away I see stuff here that I gotta wonder about, like this wire. I don't have to wonder, I can already see stuff. I can already, oh my gosh. So, this wire is hooked up to a resistor right here. It's just floating. Okay, it's just a floating connection. And that's not how these things are manufactured. So this is the sign of something. Follow it over to this. This is not original. This is an added part. Oh. Like, what are you adding parts for? And he hasn't written anywhere what he's done, so I could see, I can see that these wires here are twisted very tightly here, coming all the way down here. Wait a minute, this is going into a clip that looks original. So these wires look original, but this does not. Maybe I'm mistaken. I mean, there's space up here for it. So where is this pair of wires going? Anyway, it's going on the tone control. What? It's definitely not a wire. Connected to the what I believe to be the tone control with the broken on-off switch. Tone control can pivot. It's okay, it's just loose. I think this is a replaced control too. I mean, it just strikes me that this looks replaced. Don't know though. Probably not. Probably original. Why would they have, well, we're going to end up staring at the schematic. That's where this is going to end up for sure. Trying to sort this out. I'm lamenting because it took me how long to figure out what happened to that amplifier, and there's only 3 parts in it. And we are going to be on the schematic pretty quick here, I think. I'm looking for any other anomalistic stuff. So there was this capacitor that I changed, which is also hanging on the end of a wire, which is a weird thing. Why that would be done. A huge paper capacitor left in here. Why? I don't know. Why would he leave that? There's another one right here. There's this unusual capacitor here. So the terminal it's soldered to is practically broken off the terminal strip. That's why I can wheel it like that. This doesn't look original. What is this? It looks like an electrolytic capacitor. What's it doing there? I don't know. Don't know. So maybe look into what this is too. Let's start by looking at the schematic for what this is. You can trace it fairly easily because the wires come right off of this control. So we should be able to just zoom it right back and find out what is supposed to be there, if not that. Okay, here's the schematic part of it anyway, and what we were looking at was something hooked up to the tone control. So first we got to spot the tone control. Wow, look at that. Audio choke, filter choke, transformer here. Wow. If I were a tone control, where would I hide in the schematic? I would hide around these 45s. Of course, I'm not a tone control. Now there's something there. Audio choke with, that's probably a tap, not a, it's not an adjustment, it's a tap, I think. R14. Well, let's start with the volume control. It's going to be off of the detector. Here's the detector. So the output is here. I think. Wait a minute. Whoop. The output. Yep. So the signal gets to the grid usually through the volume control. Would that be it there? That looks like it. Oh yeah, we haven't even mentioned this expander and expander amp. What these guys are. This is something very unusual in this receiver. And the other thing we need to chase down, I'm just remembering this now, is what did he do about the missing field coil? Oh, too much on my mind. Expander switch, so that's that switch on the front with the 4 terminals on it. Turn on and off the expander. Where's your regular run-of-the-mill volume control? Unless that, well, that must be it. Because the signal has to get to this grid to carry on through the rest of the radio, and it's getting to the grid through here. So this must be volume control. It's right on the volume expander. Okay, they just didn't label it. So maybe this R14, maybe that is the tone control. Let's look in the parts list. What was that again? Short-term memory, R14, wasn't it? Yeah, R14. Not down here. R14. Here it is. Tone control SAC switch. Oh, and AC switch. SAC switch. Okay, so that's the tone control, and then volume control is 15, and I think that was the number that was appearing against that down here. Okay, so volume control is your basic run-of-the-mill volume control, so I could easily tap a signal off of here, and we will hear it. Great. Okay, so now we follow the tone control. So this must be the audio choke up in the corner there. So this audio choke has 2 wires connected to it. The audio choke that's in there is it a transformer or is it a choke? Okay, I'm sticking my finger in behind it in case you're wondering what I'm doing here, trying to feel if there's any output terminals. I can't feel any. I think that's a choke, or it's being used as a choke. So I think that's what this is. Up there. One lead is capacitored here. Okay, so I don't know about the wiring, but let's see. So if you look at the outside wires of this choke, one goes to one end of the tone control and the other goes on the slider. Excuse me. Let's take a look back yonder. So 2 wires come down here. One goes onto the middle terminal here, and the other one goes on an end terminal. That'd be it. Okay, so this is a legitimate part. Whether it's replaced or not, I'm not sure. I could easily be wrong about that being a replacement. Not the kind of thing you would replace, I don't think. I mean, it's not the kind of thing that should require a replacement. Good enough. Okay, now last mystery is, and what about the field coil? So we can start looking at that. We're kind of down here, because the field coil is powered from this power supply. It does not appear to be part of the power supply filtering system. Filtering is done with choke coils. This might be one of them right here. And there's another up on top, another 2 up on top. And an odd plate here. This does not look right. So that plate is covering 2 holes in the top. 2 component holes. It looks like for more capacitors, what it looks like. Is that plate original? Are these capacitors original? I don't think so. I don't think so. So what all? So it could be that there were once 4 single section capacitors here. Now there's 2 multi-section capacitors here. Something like that could have happened. The last repairer may have put this plate in to cover the holes. I don't know. I guess there could also be revisions in the manufacturing factory environment where they're working along with, 4 capacitors here, and then somebody does an update and goes, look at this. We changed to 2 multi-part capacitors. We save 18 cents per radio. Let's switch. What about the holes? Well, we'll just throw a plate. Haven't we got a bunch of these plates already? Put them on. So why change these resistors? Well, you change them because the other resistor was shot, or you change them because you've changed enough stuff that these got to be changed out too. No, I don't think that's the case. Well, wait a minute now. On that amplifier, the output transformer that it's confusing. There's an output transformer for the 245s here on that amplifier, and then there's another output transformer on it. The transformer for the 45s are the 2 cobbled together units underneath the chassis. The one up on top, I never really looked at that closely. I never showed it on camera that closely. It's a really old one. It's much older than this radio. It's another cobbled in part. But that's got nothing to do with this guy back here. That's all about the amplifier. So what I'm doing here, you're listening to me just roll around in my head everything I've seen and done, trying to catch up with anything that might be really out of whack. There is something really out of whack here. Let me just switch cameras. in. That screw and its washer. Now it's harder for you to see, but I think what he's done there is he's put a washer under the nut so the nut's grab is extended out to catch a little fringe of metal there. You can barely see it. It's like grabbing onto the edge. Well, what's going on there? That shouldn't be the way that is. That shouldn't be like that at all. So that is over here where my finger is. Funny there. It's just a can. What's going on there? So if we look at these, so there's three. Okay, so something just went through my head. I won't even say it. So there's three cans up on top. 1, 2, 3. And you see 1, 2. Whoop! Those aren't cans. Those are tubes. A little further back. Can, and then this can down there. You can just see the top of it. 3 cans for 3 holes. So this can is screwed in, has these threaded tails that come down through the chassis, and you bolt them in. He's bolted. Almost underneath that nut there. Looks like these have been taken off. So here's the next one, a nut and a nut. And then here's the next one, a nut. Sorry for the focus here. And then, whoop, what's happening there? You got me as to what is happening there. I don't know. It's as if the can, these 3 holes were made for 3 large cans. And up on top, we got 2 large cans on a smallie. One screw of the small one is going through the proper screw hole here, but the other one is a smallie. It can't make it all the way. Well, there's a nut in there. There's a nut in there. Whoa. What's that holding? What's going on here? So, okay, so this edge doesn't line up with this edge. It's set back. The screw holes all line up. There's a screw in there. Right, so he's lined it up on the top edge. See, they're all lining up nicely? But he's come short on the bottom. He's left the original screw in, and then he's tried to get a grip on this with the washer nut technique. I mean, I've done this kind of thing too, in some circumstances. So you know what that says? That says this is not the original coil. Oh my, really? That's not the original coil. I mean, look at the wires coming out. See how they're all just kind of bundled up here a little bit? They're not bundled, but I mean, they're bent. They're quite bent and knurled around a fair bit. This guy's floating. Oh my gosh. So many thoughts going through my head here. Oh my gosh. How's all this happen? Basically, electronic device is a little like a chain. You pull on it, you pull on it, you pull on it. One day the chain breaks. You're going to find out it's only one link. this guy's replaced links, and I'm not talking about worn out capacitors, I'm talking about coils and stuff like that. Things you never replace unless they are, burned out, open circuit, that kind of stuff. If you open circuit this, you got to bet and radio stops working, and then people stop playing it, and then nothing else happens to the radio. It gets in the hands of this guy, and he manages to change this, change output transformers. Oh my gosh. How many links of the chain can break in this radio? Now, it is possible to have things go wrong in the radio, a radio. Performance is going downhill. And the owner's just compensating by turning up the volume. And so you could have a lot of dilapidated stuff in a radio like this and still have it in use. And then have a part actually break, maybe a tube fails or capacitor shorts or something. Take it to the repair shop. The guy finds the immediate cause of the failure, but he also sees all this other stuff. But that other stuff would be degraded parts. It would not be open circuited coils. So what happened here? Unless that guy's working on the unit and breaking it at the same time, which is possible. And you change all these capacitors. Look, some of these resistors are, like this one really overheated badly, burned everything off of it. This must have been quite a smoker. It wasn't hot when we ran the set earlier and I tested it. It was just warm. It wasn't hot enough to do this. So this could have been the guy that was supplying the current that eventually burned out the coil. So my understanding is the radio was operating. Then it was moved from location to location and suffered this rather horrible damage up here. And has not been played since. Now that story may not be quite accurate, but that's kind of what I got in my head right now. So the demise of the radio was a mechanical event up here, nothing to do with anything going on in here. The most recent demise of the radio. We don't really know about, I don't know about the details of how it got into a shop in 1998. These are loose. Oh. So, yeah, right, I figured out that he managed to get down in there and change some of the capacitors down there. He's been selective on the capacitors. And every capacitor he's changed, he's just used a different type every time, which really raises my hackles. Is that the right thing to say? I have raised hackles. I don't know what a hackle is. Boy. Well, I think the only thing we're left with is plugging this guy in and seeing if I can get some sound out of it. I think we're going to jump. We're just going to jump. Instead of staring at it here, let's listen to this thing. So to do that, I'm going to stop the video for a minute while I hook up some equipment and sort that out and get the leads and everything, and we're going to turn it on. Why not? Okay, let's see how this goes. Now I've been doing a little bit of circuit tracing and whatnot, and I think I'm on my way to discovering what happened with the field coil. So I thought, well, let's get this up on screen. And this also gives me a chance to correct something I said that was wrong. And thank you for the email setting me straight once again on the humbucking coil here. You know, I've known about these coils since I was quite young, and I've always thought of them as just a hum killer, but it's a little more specific than that. The hum this bucking coil is killing is the hum coming out of the field coil here. So this field coil is a great big coil in the back of the speaker, produces the magnetic field for the speaker to operate with, and doubles as a filter in the power supply. Consequently, it has a little bit of hum in it. It's a great big coil sitting not far from the voice coil. and there can be a magnetic interaction between the two, and so the hum in here will show up in here. Maybe even electrically it might induce the hum, not so much magnetically, it may actually induce it electrically inside here. So to compensate for that, another coil is put in line with the voice coil. Now notice mechanically it's not shown in the same lineup. This is a hint that this coil is not traveling like the voice coil, it's somewhere else. And this coil is designed to produce a force opposite to what this one is doing in terms of the hum, and buck the hum away that way. So can this control hum in the power supply? Not really, except it's the same hum we're talking about again. So in a roundabout way, yes it can, but only if this field coil is sitting here. Now the speaker that's in this radio is not the speaker at all, so this is all missing. All there is a voice coil. This is all missing in the radio. In fact, so that's what we're dealing with. What has he done that this coil is missing? Commonly, as I mentioned, the field coil forms part of the filter in the power supply. And it's probably the same, it's probably true here, but I'm having a lot of trouble. I'm having a lot of trouble. It's a lot of trouble tracing this thing. So, the plug down here, the cord plugs in, that travels over to the amplifier, is represented loosely by these wires coming out of here. Loosely. There's actually two plugs out of the amp, one heading to the speaker, one heading back to the receiver. One going back to the receiver carries with it two wires from the missing field coil. When we look in the radio itself, where the field coil would be plugged in here, now why? That's right. The field coil has, I forgot for one. The field coil has to be plugged in here and go through this, because the field coil is on the speaker, and to get to the speaker you got to go through the amplifier physically to get into the speaker cable to travel out to the speaker. Okay, so that's why the field coil wires show up down here. But of course this has been completely redone. This is not the same thing anymore. There's nothing here that I can look at that relates back to that schematic. So what I decided to do was, just before I switched the camera on, I decided to identify this transformer. So this is the input transformer to the 245s. And after looking at the various transformers, this one, that one, I settled on this one up here. This must be it. This one has a wire in, wire out. It's a choke. There's another one up on top, same thing, it's a choke. This one has 5 wires. This is a transformer. There's 2 wires coming in this way and 3 wires coming out here. I feel like you can see the 3 wires almost right here. Coming right in here. So this is the input transformer to the 245s, which is what we're looking at on the schematic right here. So the center tap coming out of the transformer is going to come out on the side of the transformer with 3 wires. The other side is going to have 2 wires, and in fact that's the case. There's 2 wires coming out of the hole here and 3 wires back in here, which are very hard to see. 2 of the 3 wires go straight to the 45 tube bases, probably, and in fact they do, because I already traced that part. So that leaves one last wire, and that's the center tap wire, which is heading right for the resistor I want to identify, which I didn't make clear earlier. If you work your way back from the field coil, the first components you come to, this capacitor, this resistor. Trying to find these in the radio is dependent upon starting at a known point. Just trying to spot these, God help us. Even if I read the value on the value list, the value of this capacitor, and then try to find that value in the radio, which is kind of a crazy way to do it, for all I know, the repair guy before me changed this capacitor and changed the value too. So I don't know. So to find this resistor, got to find this, which I did, got to find this wire, which I have, and then I have switched on the camera. Okay, let's get a little closer here, because the action is all down in here. Which wire is it that you have found? this one right here. This guy. It's coming up to a terminal strip, and the terminal strip on the ungrounded terminal. Oh my god, the terminal strip appears to be replaced. Stay on track there, Jim. So it comes up, hits the terminal. The only thing connected to it at that point is this resistor. Green, blue, orange. So green and blue. Boy, those are colors I'm not that familiar with. 59, 59K doesn't sound right. What's it say on the schematic? It says R35. Let's find out what R35 is at this point. R35. R35. 56. Hey, you know what? That's right. That is what that is. That 9 is actually a 6. Blue is a 6. Green is 5. So there it is. So I found it. Now what am I going to do with it? So you know where I am. That's the main. that's the main thing. I know where I am. Down here. Now I know where I am on this. So I got my finger right on this resistor here. So look at this capacitor. See the big orange drop hooked up to the resistor on the transformer side? Yep. Right here. And going to, almost certainly going to ground. Yep, going to another terminal strip. Grounded. That terminal strip looks different too. No. Don't even think that. So that's it. So there we are. So a great big capacitor here. Physically, I can't see the value of it. It's supposed to be, what's it supposed to be? That looks like 62 to me. Is that right? 34? 62? How did that number get so high? 30. See? Oh, what happened there? That's a disaster. That's a disaster. Here we are. See what I did? I tried to click on one of these. That's what I did. So I want to, hang on. Let's make this a little bigger. I got to read that number. Read that number. See? It's a really poor 3. It must be. Here's 31. It must be 32. Oh my God. Yeah, that's R32. Okay, so occasionally these radios, they don't actually number every individual part. The number relates to a size. So for instance, if there's 5 resistors like this, all the same size, they can all be numbered the same thing, R31. I don't know what they've done in here yet. Looks like they're all different numbers, right? You never see the same number twice, like R32 and R32. So if it's C32, okay, let's just run with that. C32. Let's go C. C32. C, it's not going to give us much of a hint. It's a tiny capacitor. Molded. It's tiny. And that orange thing, that's not tiny. And this is the way it's going to go through this whole radio the whole time. It's just going to be like this. This is definitely the capacitor that's in the position here, which we don't know the number of. For sure. Just my luck. So what about this capacitor? So that would be connected to the other end of this resistor. And so let's go look. So here's the other end of the resistor. There's a wire on the terminal. It comes down to this thing. Down on this tube. This is one of the 45s. other side of the resistor wired to a 45 pin. Okay, look at the schematic. Other side of the resistor wired directly to a pin. Field coil. Okay, let me try that again. So we're coming center tap of the input transformer to the resistor, green, blue, orange. Over the other end of the resistor, this wire is connected. Appears to be nothing else connected there. This wire goes to a terminal on the output tube. On the 45s, not really the output tube, where there is this suspicious, what I think is a suspicious capacitor. So that suspicious capacitor, does it go to ground? Doesn't seem to. Hooks up to a wire that travels way off over to the tone control. Two wires from either side of this capacitor appear to be going over to the tone control. Does that add up in any way? Where'd that sneaky tone control go? Anyway, so it's up over here. A little bit of trouble moving this around on the screen, so I'm going to shrink it a bit. See if we get the volume control in. I'm sorry, tone control. Tone control here. Tone control is attached outside legs of the input, which is off to the, oh, this is the output side. So the grids on the 45s are getting their supply through here, the field coil. What is happening? Yeah. What a lot of you know, most commercial broadcasts, the last thing they want is dead air, right? So a lot of dead air in this video, I think. Man alive, a lot of dead air maybe inside my head or something about this. This is you know, this is really different from anything else I've ever seen. Field coil associated directly with the grids of a tube. So they're just trying to use the field coil to filter out any stuff from the grids here. You know what? This is just not adding up. So it's not adding up at all to me. I'm going to stop. I'm just going to study this for a while quietly on my own and try to get a better grip on what is going on in here because I am without grip right now. Okay, just a moment of calm thinking, clarified something right away. So if we just go down to the power supply here, the 5Y3 rectifier, high voltage winding center tap, and we follow it up, it goes here, and then it goes over here, and then it goes, look, right through the field coil, just like any other radio. So the field coil is one of the main filters in this power supply. Or the main filter. From there, I have a lot of trouble. typically, I mean, this should be high voltage here. So high voltage to the grid. So where's this plate get its voltage? So if you follow this back, capacitor blocking there, and come down through this resistor, you connect right here. This is one of the B plus lines right here, B plus. So the plate, it gets its shot this way on this tube, a typical way. The output, if you follow the plate, it does drop right through the primary of this transformer, and then you've got the outputs, 180 degree out of phase outputs from this transformer shot onto the grids here. Center tap comes back here. Things have gotten silent again here. I thought I had a really good grip on this. What happened to me? So again, high voltage supply coming here. Could go this way. It would find its way onto the grids as a bias. Yikes! What kind of voltage is this producing? That's got to be producing... Wait a minute, you know what I'm doing? I'm looking at the wrong thing here. Yes, I've been looking at the wrong thing. Okay, so high voltage coming out here, returning here. Returning. Hooked up. Hooked up to the grid of this tube. What? Down here, along here. Grid cap. Grid. Follow along further. Grid. Field coil, oops, field coil connected to grids from the return. So there is a trick you can play in a power supply where you can create a available bias voltage by putting a little resistor in the right spot, and then kind of having the rest of the radio running above that resistor, so to speak, and off the bottom you get a negative voltage. Kind of a weird way of saying it, but is that what they're doing all over the place here? They're developing grid voltages here. I don't know. I can't really fathom it just yet. This has really got me blown away. So let's jump forward. This field coil does not exist unless an additional coil to take its place was inserted in the radio. I'd be inclined to do that. I'd be inclined to maybe just grab some choke coil, 800 ohm choke coil, and stick it in there. Is that what's been done here? Something got stuck in. Okay, let's go back to looking at the radio here. So what have they done? So there's a possible added in coil here. And there's the two up on top. So let me just swing this all the way around. We've got this guy here. I mean, this sure looks like he belongs. And this one, he also looks like he belongs. These look like they belong. Doesn't mean they do, it just means they look that way. This one doesn't. This one looks a little different. It's just not completely in a can. The windings are a little open here. Choke coil or transformer? Which is it? So I can see only two terminals on it. Don't be fooled by these wires are just passing underneath it. Passing very tightly underneath it. So is this the field coil? Nice. So one of the leads is hooked right to a filter capacitor. The other lead is hooked to the other filter capacitor, the other terminal. That terminal is extended over to this capacitor. Just then going here and also disappearing on this wire. Now this wire is going upstairs here to the something up on the top. Choke coil on the top. Doesn't look like an original wire. Soldering to the can looks like an easy way out, not particularly a factory move. Could be. He screwed it into some holes. Were those holes really there originally? Did he drill those out? So, oh. You know what he's done? That is the screw that's holding the coil underneath too. So these two transformers or inductors are actually bolted, basically bolted together through the chassis. It just strikes me that if I were building this radio, then this would look the same as this one underneath. It would be in a can. So, you know, it's a tricky opportunity to bolt this in using the bolt of the one up above. It's another indication this is an add-in, and this is the replacement for the field coil. What would be the real giveaway? The giveaway would be that I could trace the wires from here back to that resistor way up here, or something like that. So let's start with not this white wire, but this black one. No, the black one's coming here too. Okay, not that one, this one. This guy here, he's going, where's he going? Sorry there, I'm not paying attention to what you can and can't see. So that wire, now I've let go of it. To this terminal. It's a busy terminal. It's got this wire, this resistor, it's got another wire disappearing up into here, and then it's got this capacitor on it too. Holy smokes. That's a lot of stuff on one terminal. One terminal coming from supposedly the field coil. So we pretend this is the field coil. Okay, now look at the wire at the schematic here. We see This one coming back, it connects to capacitor. On the schematic here, a wire, could be just another capacitor right there, and a resistor. This resistor is R35. Isn't this the one that I identify elsewhere? Because isn't R35 this guy here? Who or what is this guy? Gee, I wonder if there's more schematic information out there that has a pictorial diagram underneath this radio. Boy, would that be helpful. Would that ever be helpful? It's worth some time for me to go and look for such a diagram, because if it exists, my hide is saved here. I just noticed this. Just casting my eyes about, this brown capacitor shell is cracked right through here. Yep. So, okay, let's try some more stuff here. So we go on the other side of this choke, follow the white wire, come to a capacitor. So I look on the schematic now, get on the other side, just guessing, and I come straight to a wire, goes to a resistor and a resistor. So one side of the field coil goes to two resistors, the other side goes to capacitor resistor wire. Two resistors. I gotta go into this great big capacitor. There's a chance that the guy just created a new power supply out of his head here. Trying to marry all this up with the schematic is really I can end up having to do what I did with the amplifier, and that's draw up a diagram to get a grip on this. Why do I need to get a grip on it? Why? Because that's the kind of guy I am. Okay, let's look a little further into this thing. So it's on one of the 245s. On, you can probably figure out what that is. Coming from the tone control. Right from the tone control, right to a terminal upon which there is a capacitor. Yeah, that's right. The capacitor hooks up to this wire, and the wire goes right back to the tone control. So it's like a capacitor across the tone control. One bit on this tube. Okay, so let's look at the schematic here. 45. And how does the tone control fit in here? So this be the tone control here. You can see how it's kind of connected pretty directly to a grid. Come down here, the other grid. Where's this capacitor then? The capacitor lies kind of across the tone control. Is it this one? Could easily be if one leg is connected. One leg is connected to a grid. The lower leg here is actually connected to a grid. That matches, and the other side is connected to, well, it's connected to the slider on the volume control. That'd be it. So that's what that is. Now, that's what it is, but what is it? What is it? Okay, what is it? Can we read it? No, not like this. second here. Okay, hang on one second. Let's get this focused up here. Oh, what's going on? Focus. Ah, apologize for that. I have to redo the focus dialog box here. When I edit my videos, this is the kind of stuff I edit out. So chances are you didn't see this part. All right, fiddle with the focus. Here we come. Ah, you bum. Get in there a little lower. 0.01. 0.01. Okay, there's nothing special about it. It's not electrolytic. 0.01. It's got a temperature written on it. 71 degrees C. 0.01. So okay, so how does that factor in with the schematic? So it's this one. Here we go again. What number is that? Okay, my money's on C49. C49. C49.01. Okay. Well, we found one capacitor I'm sure the last guy put in, and it's correct. So that, I think what we're finding out here, just to kind of clear my head a second here, I think what we're finding out is that this is the field coil. Okay, that kind of like ends the questions that I've had for this. It's introduced quite a few more, but let's get on with what my real intention was, which is to get this guy playing here today. Should we operate it like this? Yeah, why not? Pick off the audio. Now, so I've got that arranged already, come to think of it. Right, so this audio cord is heading for my audio system that you're listening to my voice with. So it's not going to go. This is not going to go through a microphone, and whether this is going to work without humming or something like that, I don't know. We will see. Should work fine. So listen, just going a little slow here because I don't want to make a mistake. And I've pulled out the 245s. Plug out, the plug to the amp out, there's no B plus reaching the amp. Obviously the amp is in another room. In fact, the output transformer is not involved in that. I think we're okay. So just to explain the volume setup over here, this is my main microphone volumes, which I use, which I can turn down. Turn them up and I reappear, and the signal from the radio is on this, and I only hear this stuff as I put on my headphones, so I better listen. Let's just see if it's on. Okay, so I just realized I've had the volume, I've had the microphones off for the last bit, talking like crazy. don't think you heard any of it. So anyway, just getting this sorted out. Once again, that's probably a piece of the video you won't see. Okay, we're good. We're ready. We're all set. I think I'm all set. I'm all set here. Let's just back this camera up a little bit. So what's going to happen here is I'm going to apply power. It's going to be restricted power. The radio is going to come on to some degree, probably not enough to operate. As soon as I hit the power, we may hear something come out of here, a hum, who knows. I have the volume control connected in a way that the volume will be controlled from here, but it's also controlled from over yonder in a couple of ways. Lots of volume controls to fiddle with. And band switch. I have no idea what band we're on. Let's see, how can I figure that out? So there's four colors here on this dial. Blue, red, white, and yellow. And they correspond to different areas of the dial. Red area, blue area, and the rest is all faded or missing, in fact. So I think as you rotate this dial, these slots are allowing light to come through to light up a selection of these. So which one's being lit up? Which one's being lit up here? There is a light bulb right back there. I can see that this is the blue one that would be lit up now, and that's a short wave band. So we're going to come back. Red one, aircraft band. Or something like that. This one is well, white and yellow. So yellow is actually long wave below AM. This is AM. So it's not, I figured it was going to be at one end or the other of the band switch, but it's not. It's actually first set up. So I think I'm on the AM band now. And so what's it got for an antenna? It's got nothing. So I noticed earlier the antenna connection's a little bit damaged. The ground terminal is missing. It's just gone. So what happened to the ground wires? Flopping around back there? This is way up in this housing here. Way in there. Way in there. You can actually see it in there though, so let's just take a look. I think so, maybe push the ground terminal down into the radio and it's fallen into here. Maybe that's what's happened. Let me take a look and see. I'm just going to look with my own eyeballs. Wow. Okay, I'm going to look with the other camera because it's just too hard to see with my eyes. So that's the terminal way back in there, way out of focus. How do you like that? I can get this camera right in here. The antenna terminal there and the wire coming from it, and then you can see daylight through the hole. What happened to the ground terminal? Where is it? It could be just well, I don't know. I don't see it. It's a little hard to believe it wouldn't just be laying here, hanging somewhere in there. Oh. Well, as blurry as it is, let me de-blur it. Lots of deep breaths from me while working on this radio. It appears to be completely gone, just gone. Why? Why would that be gone? I mean, because it broke free and think I just clipped it away. Why would it even break? Well, that's just a mystery. I got no answer for that. Probably some mundane thing of little importance happened there. But you know, when you're looking at radio, somebody is altered. You just can't be cautious enough. Especially if the guy was clever. This guy was clever. Okay, I don't hear anybody saying don't do it, Jim. I listened carefully. Remember, the switch is shorted out here, so the only power on off is up here on my panel. Dim lights are in. Let's make sure we're doing just one bulb for maximum restriction. Okay, power on. So the dim bulb has come up. Can't quite see it back there, can you? There it is. There it is. Way back there. It's not super bright. Which is the green light for the next bulb. So we're already up to 84 volts. You know, I took out the two big 45 tubes that are going to suck back some power. Nothing bad's happening. Don't hear anything on the audio. Now let's turn it up a little bit. Listen now. What do we hear? We hear a nice little hum. Okay, I'm going to leave it up just a bit. Screw in the other light bulb. Raise the voltage up higher. 80 is too low. Here we go. Probably going to take it right up to 100. It's not as high as I expected. 100 should be enough. Make the set work. What do I hear? My ears started ringing. I don't know if I'm hearing that out of the head. I don't know. My ears started ringing a bit. How about some volume here? We don't have the volume up here. That's a problem. Ooh. Ooh. Okay, that's not sounding healthy at all. First thing we'll try is reversing the wires that I've clipped. What are the wires that I clipped? Careful now. So that's the problem, right there. Okay, volume's down. This is just a terrible way to do it. I've come up with a better way to do this for crying out loud. Okay, stay connected. Stay connected. Volume up. So I may be on the wrong end of the control here. In fact, I think I am, because I can see a shielded wire coming up to the other end of the control. So I think what I've done is I put a ground terminal onto this center terminal here. I put the chassis onto it. Volume down. He says, okay, take this end one out of here. Okay, shouldn't really be able to get a shock up in this part of the radio anyway. There's nothing much up here. Okay, and we'll put on the other end. I should have looked more closely when I first did this. I would have seen the shielded wire and know that this is the supplying end. I don't really want to be on the supplying end. I want to be on the grounded end. The grounded end had the grounded end hooked up backwards here. Okay, hold on, let's just go back to what I was doing and switch a couple wires around here. So I used a red wire when I say grounded end, it may not be grounded right to the chassis. It may go through a resistor or other things. Okay, so that's on there. So we'll switch these. Volume is down. Now the radio is plugged into an isolation transformer, so there really isn't any ground from the power system's point of view. And of course, this is going into a regular plugged in the outlet type equipment. Irregular. Okay. Volume up over here. Volume up. Volume up. Well, I'm not hearing anything. Is that a good thing? Maybe that's a good thing. Checking the volumes. Have we really got this going? Is this really going? Okay, at the risk of blowing your ears off. I can hear that. Left channel only in my ear. Well, I think we're listening to the radio now at this point. I'm not sure, but I think we're listening to the radio. So we're not hearing much. Turn it up. We're still on restricted power. We're running at 100 volts exactly. Can you say 100? Oh, not anymore. The little indicator light is lit up at the front that shows which band, and we are on the AM band, supposedly. I never did hook up an antenna. I never hooked up an antenna. That would potentially... Let's tap the antenna now. Just as a piece of wire. See what we hear. Oh, really? Okay, volume down. Tap again. Excellent. Let's put this on. So we have all of a couple feet of wire here. I can just get hang it up here beside my microphone. You can probably hear that a little bit. Okay, what do we get on that big antenna wire? Now we're going to tune this baby. It's pretty easy, but why does the main thing get there? It's tough. Here's the bag of knobs. Okay, so even though I'm having trouble tuning it, the radio's working. It's a little bit of a buzzy sound to it. That's got to be attributed to the way I've done this. So what I've discovered here is I can operate this radio here in my shop, no amplifier connected. I can listen to the output, no problem at all. So I can go ahead and do all the other testing and alignment, which is really what I wanted to find out. Is there anything else I need to do here at this point? Try some other bands, tune this radio better. Okay, so I'm going to stop the video. I'm going to find the knobs, or find a knob to get on that tuning thing and turn it. Okay, got a real nice knob there. Not the one that came with the set. Did knobs come with this set? I'm not sure I have knobs. So this will give me the leverage though to... Oh, I better find the headphones. You're listening, I'm not. Okay, let's see what we can get here. So yeah, the dial's messed up. And this pointer is turning free, but this white one is not. Watch what this white one's doing. I just barely moved the capacitor. You see, this is actually moving up here. This is showing the true travel of the capacitor. This must be like a fine tuning. So the numbers in here. So maybe the idea is you would tune this to roughly where you want to be, and then you've made a note of where this has to be for the station you want. So you quickly whip this very accurately to wherever you want it. See, it just goes around and around and around. So it would go around, once for every movement of 10 or 100 or something like that. If they geared it up, a lot of gears in this radio. But that's kind of, it's kicking this one every so often. So I think I'm heading towards this end of the band. Come on, any one station. Any one station. Capacitor's still half open. Any one station. Hidden quiet. Hit the end of the road here. No? That's the end of the road there. Okay, let's take it another step. We're going to hook up to a much longer antenna here. That was my hand touching there briefly. Trying to let you see what I'm up to here. I'm just going to clip this. Let me turn this down. Clip this to an outdoor antenna. But the switch at the far end of this cable is not thrown for the outdoor antenna. So I've just basically hooked it up to even more junky wire in my house. Ooh. There we go. Pick something up. Here we are. $5.90. Okay, another very preliminary thing would be to do the heat check on the back. It's been playing for a while. I'll let you listen to the radio while I run and get my thermal camera. Well, we make this long.
At Fast, buying a vehicle is easy. You always get our best price first from our sales reps, meaning no fees and a negotiation-free experience. That's it? What about the fine print? That is the fine print.
Okay, up on top, I mean, I'm no surprise the tube is hot. Everything else getting hot.
How would you drive in?
These two tubes here.
Learn more about how Fast makes buying a car easier at fastauto.com. Fast, for the love of the road.
Tubes.
He had 0 lights, 0 pumps, 0 chairs,
Yeah, just like
and yet millions of followers. The Terry Fox Run is Sunday, September 15th. Register for the run we're talking about at terryfox.org. This is Eric Thomas.
my viewer seeing the dim bulb light. It's hard to see in the camera. I can barely see. There's some red there. Actually, the dim bulb. Nothing hot up here. I'm going to rotate this around. Just cut this volume just in case we have a big crackle pop. Of course, I think on the YouTube video you're kind of volume protected big time, but I'm not here. No, so I pulled it off the antenna. We're not really interested in hearing anything at this point. We're more interested in is anything getting super hot back here. So red starts at around 30. That's pretty low. Let's take that up a notch. We'll make the red start a little bit below 40. Ooh, it's hot. Okay, so that's the tube base down here. That's that resistor right there. That resistor is 44 degrees. We're on restricted power here. Going up. Okay, so right away we see something there. It's about 60. That's this resistor here. I kind of feel the heat coming off it. Some of the heat is coming off the resistor, traveling down the resistor lead into the terminals on the tube socket. Come across here. I'm looking in the camera like you now to try to get this stuff. It's this. Oh, this one. So oddly enough, this one is not very hot. So my guess is this thing burned up from a bad capacitor. Capacitor got replaced and it's not hot anymore. This one's hot though. How hot? Pushing 60. Pushing 60. That's too hot. This one over here is same sort of deal. Okay. So, you know, it could be either they're supposed to be that hot, or capacitors are not helping, or who knows? Who knows? Lots of who knows potential in here. That's about it, though. This resistor is getting one of these over here is getting a little warm too. Not too hot, 30 something. Okay, so nothing is getting hot that should not get hot. A couple things are getting a little too hot. You know what? This looks like it's melting to me. What am I seeing there? It's turned all shiny. This one too. This looks like it's melted a bit. Now you can get a shock right off the middle of these resistors here. So I'm using this tool. Do you think it's solid metal all the way through? I don't know, but I'm not going to find out. I'm going to hang on to the plastic part here. Oh yeah, it's melted. It's melted right in front of us. Look at that. It's just liquid. I've never seen that before. Well, and what about this guy? He just is, no, it's not liquid, but it's flaking off. I have my finger touching this in the end. Probably not continuous metal through there, though. I wouldn't doubt it very much. Okay. Well, okay, so some work cut out for us here. Seems to be working okay, except we got these things overheating. We got to deal with that somehow. So you know, I'm not usually in here with headphones on, but I am now. And the microphone that I'm usually using is sitting up here, and it's pretty much pointing straight down. That's what you're listening to most of the time. I just tapped this bag here, so I'm just sort of becoming aware of. the microphone's picking that up so much. I didn't know I was tapping the bag. I thought the radio was making static. So, yeah, small things. You name it, it fascinates me. Okay. So I think that's the end. Oh, maybe one more thing would be, what is the B+? Yeah, maybe we should investigate that. Let's do that. What is the B+ in here? What is the B+? Of course, we're still on restricted power. So it's not the real McCoy. Oh. Okay, we're going to listen to a hum while I do this. Hum, hum, hum. Watching this meter here. So on the 500 volt scale, we're at 330. Probably all going to be the same. A little higher, fraction higher, fraction higher. That's a ground terminal. Oh, that's a ground terminal? I thought the electricity was going this way through here. It's going the other way. And the last term will be the same as this. 360 or so. Out on the tubes, we'll just pick any one and look for the high voltages that are on the tube. Let me pick one. I don't get my hand in the way. Meter. How about this one? What about here? No. What about here? Nope. There. How about here? Nope. Some high voltage in here somewhere. How about back in here? Did I try this one? Did the meter jump up and I missed it? How about this one with nothing, no pin? This is the last one here. Oh, it's going up there. So 500 volt scale, we're looking at 170, 140. 130, 140 there. So I don't know what tube we're doing this to right now. That's surprising. You got 350 down here. For sure the 350 should be showing up on these 45s. It can't show up in the 45s. I haven't got the wire plugged in. So the voltage that's heading to the 45s is the B+ line down here. Which is this one. 350. 350 is the plate voltage on the 45s. Less a little bit because of the output transformer resistance. 350 on the 45s. This is with restricted power. That 350 is going to go to 400. A 45 tube. 45s, I think, are kind of rare these days. Hang on to your 45s. I can't count apparently. 45, 45, 45, 45, 45. So, 45. Power triode. Out. Tube requires 4 contact. 1 second here. Okay, so I got a little bit distracted there. So I think I'm gonna stop at this point. It's another beautiful day outside, yes, and I think I got this just to where I needed to get it today. Tomorrow we'll do some more thorough testing of it. Kind of consider the situation up here a little closer with all these capacitors and hot resistors and all that kind of stuff, and make some decisions about what to do. That's the plan. Okay, so thanks a lot for watching this video, and see you tomorrow.